Hello. So thank you for watching this lecture video. So I'm sorry that I cannot go to school this Monday. So I make this lecture video for you. So hope you can watch it in your spare time. So thank you. Okay. So thank you so much. Okay. Okay. So last class we discussed something like increase or decrease based on percentage. So so we have inflation or depreciation, or something like stock market increase, sometimes increase. Let's say increase 10%, then sometimes go down or decrease some percentage, then increase, right? Or 5%, or then go down. So many things that increase or decrease. Let's say go down 20%. So increase, decrease, increase, decrease. Many things are changing like this way. So how to calculate the value after those changements? So we just use this. We say here initial value, so V0, then here V after this, so V now, so we say V now equal V0. So increase just 1 plus 10%. So we change 10% as 0.1, right? Or 0.10. Then decrease is 1 minus, so 8%. Okay. Then increase 5%, so increase is 1 plus, right? Then decrease 1 minus, so 20%. So use this way, we can easily find the value after those changements. So something if the rate is the same, like always increase with the same rate, or decrease with the same rate. So we call those things as inflation and depreciation. So inflation go up, depreciation go down. So we have this formula, right? Vt, the value after t year, so equal V0 initial value. So multiply 1 plus r, 1 plus r, 1 plus r. This happened at t time, right? T, so raised to t's power. So for depreciation, so say we'll go down to 1 minus, right? Okay. So in here, the t, the time usually is year. Like our car, after 10 years, what is our car's value? Or house, what is the value for my house after 10 years? So here t, usually we're talking about t, usually we use year as a unit, right? Time unit t is year, t year. Okay, so like my salary, just like after the year, we just calculate my salary increase or decrease. Usually increase based on yearly, right? Okay, but sometimes, or in some situations, time unit can be months, can be day, can be not always years. A typical example is our bank account. Like I deposited money into bank today, then after some time I wanted to take my money out, right? So here the time period is determined by me. I can withdraw my money at any time. So the bank need to calculate how much money or what is my balance, right? So let's check typically check those things like bank account. How can we calculate my balance in my bank account? So let's consider this problem. Suppose you deposit $1,000 into a bank with annual interest rate 5%. So here annual means the time period. We calculate your interest based on year. So here let's say final balance after 1 year. So this is easy, right? We say there's a 5%. What is the 5% interest annually? So this means like 100. If you deposit 100, you can get $5, right? $5 as interest. So if you deposit $1,000, very easy. So you can have $50 as your interest, right? So what is my balance? The balance equal my original deposit plus my interest, 50. So if after 1 year I wanted to take my money back, withdraw my money, I should get this. I should get $50 as interest, right? So this is easy. It seems easy, right? So let's check. Let's say how about 5 years? After 5 years, so we can use the same idea. We say 1 year, your interest is $50. Then 2 years is $100. 5 years, your interest is $250, right? So we say use this method. So 1 year interest is $50. 5 years, $250. So your balance will be this: 1,000 plus 250. So here we call this 1,000 as a principal. And this 250 as your 5 years interest. So we can say you deposit $1,000, so your total interest you earned is 250. Okay. So now let's say suppose this guy, let's suppose like this. At the end of each year, you go to the bank and take money out, then you deposit money back like this. So let's say at the very beginning, at the time 0, you deposit $1,000. $1,000. So after 1 year, you take it out. So after 1 year, you take it out. Should be like 1,000 plus $50, right? But suppose you put this money back. So let's say so at the end of second year. So we can regard this on the second year as 1050 is your new deposit, right? So this 1050 is your new deposit, and after 1 year, so your balance is equal thus your deposit plus your interest. So interest is 5%. It's 5% of this 1050, right? Okay, so we can say so this equal 1050. We can take 1050 take it out. So So this become 1 plus 0.005. And this is 1050. We also can write 1050 as this: $1,000 multiply 1 plus 0.005. Okay, so we find this one, so it becomes this. So $1,000 multiply 1 plus 0.005 square. Right? Okay, so we can find the padding like, okay, at the end of first year, how much you can take. You can take this just 1 plus 0.005 1. And at the end of second year, at the end of the second year, your balance will be, I just raise to this 2, right? 2. Okay, so let's say, so here, so we can say, oh, thing, so take it out, so put back, so then at the end of 30 years, how much you can take. So this equal 1,000 multiply 1 plus 0.005 is 3rd power. Alright? Okay, so now at the end of 5th year, so I just do that. So put it back, take out. So suppose this is at the end of 4th year, then 5th year, put it back, then take out. So how much we can take? We should have this equal 1,000 multiply 1 plus 0.005 5th power, 5th power, right? So we have this at the end of 5th year, your balance should be this. Okay. Okay, so from our calculate, we find this number is this: 1276.28. So we calculated before, like we say, oh, we say this equal 1,250, right? So let's say, what is my balance after 5 years? We have 2 answers. So there's 2 answers. So which one is correct? We say both of them are correct. Both of them are correct. So those 2 different answers come from different calculation method. So we call this one is simple interest. This method we call it a simple interest formula or interest method. This one we call compounding interest formula, compounding interest. Okay. So what is their difference? Difference is like a calculation method. Like, okay, so this one is, at 0, at the beginning, I deposit $1,000. Then I do not calculate. Like at the end of 5th year, I just take it out. Okay, put it back. Like, so input, say like a deposit thing, just after 5 years take it out. So I just check, along this time period, what is your interest? So we say 1 year is 50. So here 5 year, 250, right? So for this one, at 0, I just calculate your balance at the end of each year. So calculate thing. I just let's say so the customer do not take out, right? So we can regard it, we just regard it, we put this back or regard this as a new deposit. So just saying like take out, put back, take out, put back. So take out, put back, saying take out. Okay. So here we can regard calculation time, like calculate many more frequently, many times. Okay, so we say there's a compounding interest. Okay, so we call this a compounding annually, meaning for each year or compounding yearly. For each year, just calculate it one time. So now let's say, so how about compounded monthly? Let's say I just do this. Let's say at the end of each month, or the bank just calculate your balance. So let's say 0, so deposit $1,000. So here 1 year, 2 year, 3, 4, 5, like this. But here at this first month, I take it out, come back, take it out, just put it back like that. Okay. So here we can look at time period is months, or the bank will calculate your balance for every month. So let's say, so at the end of the first month, 1 month, what is the balance? So your balance is your deposit or your principal, 1,000, plus your 1 month interest, right? So your annual interest is $50, 5%, right? So 1,000, 5%, $105, $1,050. But 1 month is just 50 divided by 12, right? So this 50 is 1,000 multiplied 0.005. So we can take 1,000 outside. So we have this equal 1,000 multiply 1 plus 0.005 over 12. So we can regard this 0.005 over 12 as monthly interest rate. So we say the 5 interest rate is for annual year. For 1 year, I give you 5%. So 1 month, I can only give you 5% over 12, right? Okay, so use the same method. We can find at the end of second month. For second month, my balance will be this. I just raised to 2, right? So here, just 1. We say 1 plus this interest, monthly interest, 1 plus, we can regard it as R, right? 1 plus R is 1. So at the end of second month, 1 plus this R is 2. So this 0.005 over 12 is a monthly interest rate. Okay, so we can continue to do this. So let's say at each month, I just do this. Then at the end of 5th year, so let's say 5th year is how many months? So 1 year 12, 5 year how many months? Should be 60 months, right? 60 months. So at the 5th year, or at the end of the 60 months, your balance will be this, equal 1,000. 1,000 multiplied 1 plus this rate, 0.05 over 12 raised to 6 power. So 60 comes from 5 multiplied 12, right? Okay, so we got this number. Okay. So we can say this is, so we call this a compounded monthly. And we can compare this number with this 1 to 76.28. This is annually or yearly. So this is monthly. So we find this result. We say compounded more often, we should have more money. Like simply, so let's say we put those numbers like simple is 1 to 50, and then we have 1 to 78. Let me see. Annually is 1 to 78, 20. 1 to 78.28. And then this one is 1 to 83.35. Okay, so after 5 years, what is my balance? So which is my balance? So this is really related to how the bank count your balance. If only count one time, or it's a simple interest formula, thus, right? If you count every year 5 times, we got this. If you count every month or 6 times, we got this, right? Okay, so from here we generalize this. We have a formula for compounding interest formula. So compounding interest formula is, so AT means amount of your balance after time t. So here t still is year. So equal principal multiply 1 plus r. So r is also for annual interest rate. So here r divided by m. So what is the m? M is, we just for 1 year. Now 1 year you cut how many times? So 1 year. We can cut 12 times, right? So if we cut 1 year as 12 times, so we call this is a compounded monthly. So here M is 12. So we also can cut 1 year into 4 time period, right? 4 parts. So we call this a compounded quarterly. Or if we count every day, then 1 year we just split 1 year into 365 parts, right? 1 year equal 365 days. So this M is just 1 year how many times we cut. So T year we will calculate or cut it or MT, right? So here if m equal 12, so we can say m equal 12, then 5 years. Here, this mt, the t is 5. And this and this time t is usually for year. Okay. Okay, so R over M. So R is annual interest rate. Okay. Okay. So we can say like, so we say like, so M, we say what is M? M is the number of compounding period per year. Okay, so 1 year, how many times? Or compounded, or calculate how many times? So m equal 1, we say compounded annually. M equal 12, we say compounded monthly. So m equal 365, so we say compounded daily. And by the way, so there's a simple interest. We just calculate this way, equal principal plus interest. So this interest I just calculate one time. So how can we calculate the interest? We just say 1 year is PR, right? Principal multiplied the percentage. So this is 1 year interest, P times R. So T year, I just multiply T, right? Multiply by T, okay? Or T years. So here T can be any time period. Can be like 1 month or like 35 days. We can use this formula. Okay. So we also already mentioned the difference between simple and compounding interest. The difference is calculate times. So this one simple, we just calculate one time from 0 to time t. So here deposit put and then take it out. I just calculate one time. And compound interest, I calculate many times, like deposit then take out back, take out, put back. We just calculate many times, right? So as a function, we say like this one simple interest formula. This function about t is a polynomial function. Okay, and so for compound interest formulas, this one as a function of t, so this is exponential function. Okay, so we say as a function, one is a resultant function, one is a polynomial or linear function, then the other is a exponential function. Okay, so here we mentioned compound more often should have more money. So let's consider this problem. Let's confirm this. Like suppose like you deposit, your principal is let's say your principal is 20,000. So this is not small money. So if we deposit a big money into bank, into somewhere, you need to check how they are calculated your balance, right? How they are compounded. Okay. So let's check confirm this. If we compound more often, we should have more money. So annual interest rate is 6%. Okay, and t is 3 years. So this t is equal 3. Okay. So if we compound annually or monthly or daily, so we we can know we can know more often should have more money, right? So daily says one, we should have more money. So let's confirm this. Okay. I'm sorry. What's let's see. So here, let's use the formula. Just okay. A3. We just calculate the same number. After 3 years, what is my balance? So compound annually. So here m equal 1. So we just plug it in. The m is 1. R is 0.006. So just raise to 3 power. We got this. So so we can say deposited $20,000. We have, let's see, so $3,820 as interest, right? So for this one, so compounded monthly, so should it divide by 12? Yeah, so this is divided by 12, and then so here the 3 multiply 12. So we also can understand that this is 3 years, how many months? So when you put this into calculate, this should be one number. Okay, this raised to this power. Raised to 36 or 3 multiply 12. Because this is one number, this power. So we get this. So you can say money increase, right? Increase about $10 more. So here, if compounded daily, daily is equal to 0.006 divided by 365. So then raised to this power 3 multiply this. 3 multiply this. So 3 multiply this is like the 3 days of 3 years. How many days in 3 years? We have so many. Or we also can say like if they calculate daily, so how many times the bank should calculate. Okay, so we got this. So we can say we can expect from here to here also increase. But so here increase the difference about $10, but here just a little bit. Oh, I'm sorry. Oh, this equal let's say more than $100 difference. Yes, yeah, more than $100. Actually, $10, right? So from here to here, $10. But anyway, increase, right? Okay, so here we just confirm. I use the 2 examples. From here we say compounded more often, we should have more money, right? Yeah, more often, more money. So then let's consider how about compounded instantly. Or always calculate like compounded. Let's say, or we can say m. How about we let m goes to infinity. Let me say, like we say we can compound it daily, right? We also can compound it hourly. So one day have so many hours. We also can compound it minutely, right? Or secondly, like those m become bigger. So should we have more and more money, more money? So we say our money increase, but we have a limit. So we call this limit also like asymptote. Like it always increase in my money increase. If we company more often, so my money increase. But there has a limit. So they are just close to this, right? So just like we call this a limit. Or just like asymptote, close approach to the asymptote, right? Okay, we'll approach this. So we want to find the limit. So here we say as m, so we use the notation limit, lim, limit. As m goes to infinity, this one, we have this formula equal p ERT. So here P is principal, R is annual interest rate, T is time in year. So what is E? We say what is this number E? So E is a constant, is a fixed constant. This is just like a pi, like this is a fixed constant. This is very important number in mathematics. And we call this formula AT equal PRT because this is compounded continuously. So this is just a limit. So compound more often, you cannot, at most you can just reach to this limit. You cannot have in lots of money, right? Okay, you have a limit. So let's say, let's check this. Like, if your deposit is big and the time period is long, then compounded, then the calculation method can produce big difference. So let's check this problem. Like you deposit $10,000. Okay, so annual rate is 6%, and T is 10 years. So you deposited $10,000 for 10 years with the annual interest rate is 6%. Then we want to find your balance after 10 years. What is the balance? So we say what is your balance depends on how the bank calculate your balance. How bank calculate. So let's check there's the difference. A, if it is calculated by simple interest method, simple interest formula. Or B, if it is calculated or compounded annually. C, it is compounded continuously. So let's check their difference. So for A is very easy, like compound, there's simple interest is so simple interest 1 year 6%, just 6% interest rate. So 6% 1 year. So here like $10,000 equal $10,000 is 1 year is 600, right? Let's say so. This is easy, like actually $106, right? So here there's 10,000 so equals 600, right? And then 10 years, just multiply 1 more 6. So 10-year equals 6,000. So this equal, this multiply this 1 year, saying 10 year. Okay, so we got this number. So we say you can have $6,000 as your interest. Okay, so this is A, easy, right? So just we say 1 year how much? Saying T year just multiply T, right? So 1 year 600, 10 year 6,000. Okay, so now how about compounded? Compounded, so let's say compounded annually. Compounded annually. So use this formula. Annually 1 plus 0.006 raised to 10th power. Right? So P multiply 1 plus 0.006 raised to 10th power. So we got this result. 17908. Okay, so their difference, we say like simple interest and compound interest, their difference is huge, right? More than difference thus. So this is big number, right? Almost $2,000, 1,900. Then let's check a compound. How about a compound continuously? So continuously uses the formula PERT. The P says E is fixed. R 0.006 multiply T 10. Okay, so in your calculate, you have E button. So EX button. So check your calculate, find this button. So E raised to this power. E button, so what is X? E so raised to this power. So this is one number. 0.006 multiply 10 as one number. So check your calculate. Check your calculator to do those calculation. Okay, so my result is this. Okay, so we say so we can say like, so this is like a compounding limit. So this should be larger than this. And from here to here, so this is like a possible biggest difference between simple interest and compound interest. So we can say those difference is 2020. The difference could be this, right? 2,200 difference. So this difference can be significant. Okay. Okay. So we can have those kind of problem. Deposit $1,000. Okay. So we have, let's say we have those kind of problem. So let's say suppose like you deposit $1,000 and you hope $1,000 will become $2,000 in 10 years. You hope after 10 years you deposit, your investment will be doubled. So the question is, what is interest rate? What is the minimum interest rate should it be? So we say for calculate those things like a bank account, we need to know which formula to use, right? Or we need to know how the bank is calculated, the bank account is calculated. So this is the keywords if it is compounded annually. Okay, compounded annually. So we just use the compounded annually formula. So let's say compounded annually formula. You say AT amount of my money after the TA equal principal multiply 1 plus RT, right? So this is compounded annually. So we also can regard this M is 1 year, 1 time period. So just plug in this formula. So here we say P principal equal 1,000 and T equal 10. And so we 18 that we hope this become 2,000. Okay, and 1 plus R, so raised to 10th power. Okay, so we get this equation. So how can I find this R? How can I find this R? So at first we simplify, yeah. So we just divide 1,000. We say 2 equal 1 plus R 10th power, right? So how can we solve for R? How can we solve this equation? We say, oh, change this 10 to 1. So how can we change this 10 to 1? We just take 1 over 10th power. So we get this 2 1 over 10th power equal 1 plus R. Right? Okay. So 1 over 10th power 2 0.1 plus power equals this. So R, you see, so R equals this number. So we also can say this is 2 0.1 power, right? Minus 1. So you calculate, so you can find this number 2 raised to 0.1 power. So in your calculate, so please find this button y's power, like x y. Use this button maybe. Okay. 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 So now let's consider this problem. Quite the same, but this time if it is compounded continuously. So we should use compounded continuously as a formula, right? So we say AT equal PERT. Okay? We should use this formula. Okay. And we just plug in here. So here we deposit $1,000. And after 10 years, we hope the money will become 2,000. So we plug in here P equal 1,000. So R we don't know. T is 10. Yes. So AT amount or my balance after the 10 years, the T equal 10. 10 years, I hope says my money will become 2,000. Okay, so we have this equation. So for this equation, our first step is simplify. Like divide by 1,000. Oh, just 2 equal E. So here R times 10, so just 10 times R, right? Okay, so we have this equation. So for this equation, so we have some trouble. But let's say, So here we just in previous equation we just change this thing to 1, just take 1 over 10's power. But this way, if we take 1 over 10, we still cannot solve for this r. So actually, so this different equation. So this equation, the unknown variable, this r is at exponent position. So we call this equation as exponential equation. Okay. So because unknown variable is in at this exponent position. So before the previous equation, we call this as a polynomial equation or power equation. So what's the difference? So let's check these two equations. Okay, x2 equals 5. Okay, and this equation, and let's say 2x equals 5. So these two different equations, like we say, like for number, like say a, b. So we call this a as base, b as exponent, right? So in here, unknown variable x is base. This exponent 2 is fixed. But here, unknown variable is in the exponent position. So we call this as exponential equation, the XP equation. And this one is polynomial equation. Okay. So this is polynomial equation. Okay, so you see the difference. So those two equations are totally different. So for solving polynomial equation or power equation, we have some method. But for those exponential equations, so how to solve those exponential equations, maybe something new to us. Right? So we will discuss those things in next class. Okay? Okay, so we can stop here. Thank you. Thank you for watching, and thank you for understanding. Okay, so see you next time. Okay, see you in class.